I first saw Randy speak in 2003. I was invited to go to Walker Creek Ranch in Northern California and meet an extraordinary group of educators that I still work with today. It was truly a humbling experience. And part of my favorite moment in that was when this young guy comes over from Pixar, Randy Nelson, and he introduces himself as the Dean of PU. And we all thought that was odd until he explained that PU is Pixar University. So Pixar University was a professional development space where all the animators, all the people at Pixar came to learn. And Randy was the lead learner at Pixar. And it was extraordinary. I was moved. And so I've been following his career ever since. And by following his career, I mean, harassing him until he would come and keynote at Q. So he finally relented.
That's great. Thank you.
Just realized it wasn't plugged in.
So, how about a round of applause for one of the best tap dancers there is?
And now you're telling secrets.
Well, aren't we going to demonstrate?
Oh, we could. We could certainly. I'm not going to turn that around. And we'll finish with a pullback. There we go.
See, you recognize that bow? I got a call once from Steve Jobs, and this was when I was working at Pixar, and he said, "My friend Ken Burns is in town. I'd like you to show him around Pixar." Talk about a cool gig, right? So you know Ken Burns, the documentary filmmaker, right? The Ken Burns effect inside our iMovie. And we're walking across the center of the atrium, and Ken stops me and says, "Break a leg? You know the expression break a leg? Well, I am a former ballet dancer. That's about the only thing we knew firsthand, is that ballet dancers were the one class of performing artists you don't say break a leg to. Do you know what you say? Any dancers here? You say merde, which is French for do good. So he asked me, do you know what break a leg means? And of course, we've all heard many stories over time about the derivation of a particular phrase that seems to make sense, but in a strange way, we'd love to know the real truth. And coming from Ken Burns, I'm pretty confident this is the right story. If once upon a time you were a performer and the king required your presence to come and perform for the royal family, it wasn't that they were watching your performance. There was no radio then, right? You're just background music. But if your performance was so good, so riveting, so transporting that they actually looked up and paid attention to you, you had to pay attention back. And at the end of your performance, you needed to acknowledge that. And you would break a leg. So may your performances for your students always be so good that they actually look up from what else they're doing and pay attention to you, if only for a moment. In which case, you know what that is? Sputnik. Yeah, exactly. 1957, and I was almost 4 years old. We lived in Tucson, Arizona, and my parents got me up, and we went out in the backyard, and we look up at the sky, and they explained to me, as much as a 4-year-old could understand, Sputnik. I will never forget that. My dad's big man. My brother's big, Tiny and Teeny Nelson. My mother was tiny, and we're all in the backyard staring at the sky. I must have been held up because I was just tiny. And this thing went over, and I'll never forget seeing it, staring at the sky. But what impressed me more was the fact that my unshakable, brilliant parents seemed to be concerned about something that they couldn't explain, but they got me up in the middle of the night to see this thing go through the sky. It was an amazing thing, and that has never left me. And I think that the space program was transforming for many of us as part of the power that has led to this technology revolution that allows us to be here today using technology in the classrooms. Really significant, though, just 2 years later, 1960, so a little more than that, and there's a television program, talk about the digital natives. Well, then there were 3 channels, a different world. And there was a program that honored the children that had been born after 1957 because they were the children born with stars in their eyes, the children born after Sputnik, children born in the space age. I was 6 years old, and I had been passed by. Born as I was in 1954. I tell you, I was a troubled 6-year-old. I didn't know how to accept this information that I was already out of step with the future. Well, I did my best with my ABCs. With my ABCs of technology. Isn't it fun? So something isn't plugged in here. I got it. Failure avoidance and error recovery. So, when you think about the ABCs of career, for me as that 6-year-old, it wasn't long before I began to build this picture in my mind. And remember, this was the early 60s. And in the early 60s, there was absolutely no question about what your ABCs were. A, you wanted to be an astronaut. No doubt about it. If you couldn't be an astronaut, being the Beatles would be okay. That one appealed. I wasn't sure what C was. But then, not long after discovering the eyesight needed to be an astronaut, disqualified me somewhat. The Beatles' job appeared to already be taken. But astronauts used computers, and I had to know about computers. Now, I have a disability. There's a scientist at Harvard, a woman named Margaret Livingstone, and she's a neurobiologist. And she figured out that by studying artists, she could learn more about what was going on in the brain that would validate some of the things that she was doing at the molecular and the cellular level. And so she studied artists, and one of her theses was, maybe artists are disabled people for whom this disability gives them a special insight or ability. And what she studied was, if you can draw, I can draw. If you can draw, maybe it's because the brain's ability to translate a two-dimensional image using two optics into a calculated three-dimensional image, if you were missing that ability to make that calculation, if you were stereo blind, maybe you would have an edge in terms of being able to draw, capturing that two-dimensional information that was coming into one of those two eyes. So she studied it. One of the great things about being a college professor, graduate students. So with an infinite supply of graduate students, they went through all of the modern artists who were keyed as being able to draw and looked for whether or not there was evidence in portrait photography of them that their eyes didn't match, that they had potentially stereo blindness. And she discovered a very high correlation, almost 60%, between artists in the modern era who we credit as being great draftsmen and artists who are themselves stereo blind. Remarkable. I don't have stereo blindness, but I can draw, and I recognize that it's a strange thing to be able to do. And throughout school, I was always shunted off into the back room when everyone else had to practice their fractions. I made the calendar. And I always thought it was unfair. There had to be some way, I thought, of extending that special status I got for no work on my part. It's a gift, for God's sakes. And how every student could be that same special person who got to sit in the back room and do that special project with the teacher. That's why I became an educator. So my ABCs of career development, astronaut was out, Beatles was taken, but computers represented a remarkable introduction to all the things that I wanted to do. And I studied NASA incessantly. And one of the things that I learned was there was a particular problem they faced when choosing the astronauts. Why would that be a problem? Bless you. You've got the world's greatest sample of incredibly high-performing people. I'll say people, but it was men. And you had to figure out, once you put up the sort of standards of how do you say who's the best, it turned out there was still far too many. And so they turned the standards around. And rather than looking at incredibly successful people, what they really decided they wanted was people who had failed and survived. There was a special set of adaptive skills that were not about failure avoidance, but were rather couched in error recovery. And in fact, error recovery, as long as you get through it, is the best teacher that we have, outside of yourselves, of course. So I realized that there was something interesting about computers, about being an artist and finding a way to be special, and about the ability to give someone a chance to fail successfully. This was my big discovery. Anybody recognize this? I got a thrill when I found this picture on the internet. For those of you who don't recognize this, this is an IBM issue flowcharting template. So, in some sense, this provided an option for me to understand something about thinking as a drawing process, an ability to take problem solving as a practice and turn it into a drawing process. And I fell in love. And in some sense, you could think of this presentation as subtitled, All I Really Need to Know, I Learned Flowcharting. Preparation. What could be more important for a student? Input and output. Absolutely critical. Process. What else is there? All of those things lead to great decisions. So, with a background in coding, a life as an artist, I found that there were a number of interesting opportunities. And one of the things this led me to was when I got to the point where my juggling career looked like it was about at the right place. My kids were old enough so that they could no longer come on the road. I wrote a letter to Steve Jobs. Steve had hired the juggling group that I was a part of, the Flying Karamazov Brothers. Ho! Pavlovian, I have to do it. To do a show for Apple Computer, and then a year later to do a show for Next Computer. And at the show for Apple Computer, we arranged to be paid in Macintoshes. This was late 1984. And Apple accountants told us, no, 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 come on, this is barter. You guys, this is the, modern times. We don't do that. But when we arrived for the show, there was Steve Jobs in the conference room with the Bosendorf grand piano and 3 neat little Macintoshes. And not only that, but Steve went and got Susan Kerr out of the party. Susan Kerr is one of the original Mac team members. And she was very strange for people in the industry, in that Steve had hired an artist to be on a development team. And everybody said, what are you doing that for? You need an artist at the end when you got to do the box art. But you certainly don't need an artist as a part of a software development team. And in fact, I can't imagine today a software development team without an artist. Think of Susan's greatest work as something that will endure for a long time to come. She's the person that figured out in that 16 by 16 square how to design the cursor pointer that we all know. Can you imagine a more influential artist in our time? So Steve went and got Susan out of the party, and Susan sat down and taught me how to use my new Macintosh. It was an amazing opportunity. A year later, we did the show for Next, and I returned the favor by teaching Steve's daughter how to juggle. I later had to ask his assistant, what's her name again? And she said, Randy, just think. And I said, Lisa. Thank you. So Steve Jobs came back from a meeting with Lotus when we were at Next. And he said, good news, this new spreadsheet they're building for us called Improv, it's basically done, they tell us. And we're like, that's incredible. And he said, yeah, they introduced me to a new term I hadn't heard, MMC. Mere matter of code. The thing was completely designed. They just hadn't coded it. But the real problem of software development, the real problem of classroom design, the real problem of curriculum mastery, it's about the design. Everything else is a practice. And a practice is something we do with guidance on a daily basis. But designs, those are expensive. Those are transforming. And those are what I learned to do with a flowchart. So my notion today, MMC, there's our first of our new TLAs, 3-letter acronyms. This is one of the older 3-letter acronyms. We don't even say it right. We don't say RRR. Maybe they think we were laughing at them. The 3 R's, reading, writing, and arithmetic. And of course, any good school from that era would have also known that we have to teach citizenship. I think those are important skills. I absolutely do. But when I think about what's fundamental today, I think maybe we can recast or reframe the argument in terms of input, output, processing, and collaboration. And that's really what I'm here today to talk about, is I want to throw down this challenge to say, we have been working for integration for too long. It's time for us to put our foot down and say, programming is the 4th R. We're not asking for a seat at the table. We want the table. Software, where the rubber meets the sky. Software, the domain of all possibility. Software, one of the most amazing things we have ever created, and I'll expand on this a bit. But fundamentally, Software is a domain in which we take ideas, put them in sequence, and get products. I'm not here today as an astronaut or one of the Beatles, but I am here today as a business person. So I'm not an educator, although I have played one on TV. I am somebody who knows at the output end of this cycle that you preside over so brilliantly, I see what comes out. And I get to hire the best of the students in the world for places like Pixar and Dreamworks. And I can tell you, this is simply an observation. This isn't an opinion so much. This isn't a prescription. It's just the recognition that great organizations thrive on incredible people. And incredible people are represented by mastery in something and a broad interest in everything else. And the school system, our education, has to recognize that as we go around that palette, that selection of all of the colors there are, that there's going to be a kid that lines up with every one of those frequencies and needs his or her passions rewarded for showing up with a willingness to care about something more than anything else. Because that is the single best predictor we found of someone going to be successful. Mastery in the future is best predicted by mastery in the present. And it's a terrible chicken and egg game. Well, how do you get mastery if you don't have it? So that's really what I want to talk about. Input. Programming can stand for reading in that it provides testable solutions that can be absorbed and compared in a wide variety of styles and can be the basis not only for developing literacy, but literacy about literacy. It's a small systematic language domain in which everything about language can be explored and understood and applied to others. And we know the value for our students of providing not just here's what this is, but here's something to compare it to. That's the way our minds work. We're differencing engines. Programming as writing contains its own feedback mechanism that checks syntax and meaning and provide an element of auto-instruction and self-correction. Processing, where programmers turn ideas into products without the intermediate step of manufacturing, merely sequencing those ideas is what needs to be managed. And collaboration. Programming allows for an individual to act like a group and a group to act like an individual and enables the inevitable acceleration that is the best thing that we can hope for out of our classrooms and for the success of our students, to go from them being individuals to being able to successfully cooperate to ultimately being collaborators. Collaborators, human beings who make an amplifier out of human beings. So the 3 R's. Our goal today, our fundamentals as educators, is to produce socially skilled, independent, lifelong learners. And today that means producing people-smart information managers who are skilled at accessing, producing, and judging information. So how does programming speak to this? Programmers start by reading code. They learn syntax, sequence, and logic. And programmers learn by writing code. They design, they build, and they test models of problems and solutions. Programmers develop by judging code. They find and fix bugs to hone diagnostic and problem-solving skills. Students need to make things. We know that. Programmers make things. Students need to know why they need the basics. And programmers need solid reading, writing, and math skill. Students need to be motivated, and programmers understand from every bit of what they do the entire domain of application of all of the fundamentals in our curriculum. So can we get beyond the 3 R's? I think we can. I think we can even get from programming to things like science, where we have the domain of hypothesis, testing, isolation of variables, and one of the most important breakthroughs of the last 25 years, a new domain of problem solving through model building. I'll talk more about that. Okay, not a surprise we could get to the sciences. What about design? Programmers build things. Calculators, word processors, calendars, protein folding applications, you name it. How many apps are there on the App Store today? Building problems means solving design problems. You want to know where the future is? It's design. The place where the design happens will always be the place that controls what happens next in the economy. Yes, we want our students to be able to work in new economies, but gosh, we don't want to be somebody else's offshore. We want to own the business, and that means producing designers, not just people who can work successfully for someone else's design. This is an incredibly high calling, and I've seen this in the places I work. The manufacturing may go someplace else, but ultimately where the design is where the control and the power and the influence are. How about to the arts? Programs create experiences, often using images, sound, and other sensory content. Oops, creation of experience, that's another name for the arts. Programming requires today an understanding of the fundamentals there. 2D, the picture plane, 3D, the sculptural space, 4D, time-based experiences. Greg Brando is a friend of mine, and he's currently the chief executive of technology for Disney. And Greg once said to me, you know, history, he's quite a philosopher, it's really just revision control, right? Revision control is what we do in software. Greg speaks from great experience. Greg has the rare pride of being able to say, I once lost an entire Pixar film, Toy Story 2, and the backup process was going beautifully, but somehow something went wrong. And Greg had to go and say, you know that movie we're working on? It doesn't exist anymore. I wonder if anyone broke the rules, copied the entire film onto their home machine. We should ask some of the senior engineers. Out of this was developed a core principle at Pixar, which is that it's not about backups, it's about restorals. Okay, I'm getting a little far afield here, but programming to cooking. Nicholas Wirth. As software folks, you must know of Nicholas Wirth, one of the great authors and an incredible teacher I was lucky enough to experience. Nicholas Wirth says programs are algorithms plus data structures, and cooking is simply ingredients plus recipes. Have we missed anybody yet in terms of how programming can be an entree to a group-based process that can engage their clear passions and provide an opportunity for the expression of real products? We all need help in the classroom. Programming can be a teacher's aid because it gives you form support in the syntax of your code and allows you to talk about grammar and language structure in non-abstract ways in a fresh sample. Programming as a teacher's aid gives us an opportunity to look at the functionality of the code presented to us simply by an interaction of the student and the resulting code. Does it work? Is it a great experience? How does your user feel about it? Logic, execution, and problem solving. And it even stretches all the way to code. The result of our code is content, where we can talk about realization, design, and critique. And most of all, this is why it's an independent teacher's aid, a mentor in your classroom, is it allows for your students to make independent growth and development. A mentor for each student that's always patient, logical, fair, consistent, and flexible, and it's already in your room. I talked a moment ago about the importance of model building. Something changed recently in the way we solve problems. The last 25 years or so. And it's a function in part of new paradigms of thought, but those new paradigms were offered or became available because of the strength and the power of today's computer processing. We could not just isolate a problem by following a variable through a particular thread, but we could build an entire world in which those variables were found and then step back and do something unheard of. Not just seek to find if we've gotten our expected outcome, but to discover unexpected ones. This is an exciting world that has become the new way to solve all problems. Build that model, turn it on, step back and watch. I was at Pixar for 12 years, and it was an incredible experience because of the range of remarkable skills that I ran into. Pixar was a place that was founded on the idea that before them had been Disney, and it was a place all about the artists. And in an argument, no matter what the content was, the artists always won. Or a place like Industrial Light and Magic, where it's all about the technology. And again, in an argument, because of the supremacy of that particular part of the culture. So when Pixar was founded, the founders set out to make it an evenly balanced organization between art and technology. And they finished the first movie and stepped back and said, we screwed up. We forgot the managers, the people who keep us on track, the people who manage the spreadsheets, while we manage the technology behind them and the art that they lead to. So you may not know, because Pixar has become so clearly associated with the great films it makes, that for 10 years after Steve bought it, Pixar wandered in its own sort of wilderness, as Steve would routinely ask them, have you guys figured out what you want to be when you grow up? Payroll was paid out of Steve's pocket every Friday for 10 years. And straws were drawn. There was no business account. And Lisa Ellis, who's just retired from Pixar HR, told me this story. Straws were drawn, payroll went out, paychecks went out on Friday morning. They drew straws then about who was going to call the bank to find out if Steve had funded payroll one more week. So this wasn't a sure thing. This wasn't that clear vision that said someday people are going to want to watch movies in which whole worlds have been created and we get to look at them through a little window to see that incredible reality. Pixar did magnetic resonance imaging for doctors because they were so good at 3D they could take all of that data from the magnetic resonance imaging machine and make pictures so clear even doctors could understand them. And kidding, it's friendly. We joke, we kid. Satellite data representation that was so good, they downloaded it from what was then Usenet and did analysis on satellite data that was so good, the CIA showed up and said, where'd you get that? He said, you can't have that. And we said, yeah, it's public domain. Well, where'd this analysis come from? We wrote it. He said, let's sit down and talk. I used to teach at the NSA. In those days, I had a ponytail down here. And I was the only person at the NSA with a ponytail, male or female. And let me give you a note about security. I showed up at the NSA. It takes 2 people to walk you and your materials in. There has to be an escort badge, and there has to be a separate person who has a courier badge. So I showed up with my software to teach my class at the NSA and my ponytail. And my host was a courier. My host was an escort. He didn't have a courier badge. So he looked at me and said, stick it in the back of your pants. So that's how you get things into the NSA officially. He didn't have an escort. He only had an escort badge, no courier badge. So there was no one to actually take my material in. But that doesn't slow you down, as long as you can stick it in the back of your pants. So the animated films at Pixar were a test of the ability of that young company that they were allowed once a year to make, to demonstrate their ability to create dynamic models that were rich and high fidelity and, most important, believable. Someone has said, Catmull, the president of Pixar and now the president of Disney as well, animation studios, said, so what you guys are doing is you're making more and more realistic tools, so eventually you're going to make perfectly realistic movies. And Ed said, oh, no, 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 no. Perfectly realistic movies already exist. They're called home movies, and no one wants to see them. But you couldn't argue they're not perfectly realistic. No, our job is to make perfectly believable movies. At Pixar, one of the single most important judgments about a new candidate, regardless of what they were going to do, was could they program a computer? They weren't going for a programming job, but Pixar recognized that teaching someone to program successfully meant they had a rigorous problem-solving domain at their disposal. Isn't that a great world? To give our students a skill that becomes an entree into exactly the places we want them to be able to work. Well, I said input, output, and processing. What about this collaboration thing? It's really important to me. So, in the last 2 years at Dreamworks, I've been involved in managing the training for a complete body of new software for the studio. Actually, 2 complete bodies of new software. One for the front of the pipeline that does animation, called Primo, and the back end, which is called Torch, for lighting and everything to do with that. So the entire software pipeline, you think, gee, proprietary software today, can't you just buy stuff off the shelf? But something interesting happened in the last couple of years, which is that processors changed. And you're well aware of this, I'm sure. We've gone from having that wonderful speed bump every 18 months that came from Moore's Law. I hosted Andy Grove once, another friend of Steve's at Pixar, and we talked about that. He said, yeah, it's an amazing thing. When Moore came up with that notion, and we all went, you think? And here it has been 20 years. But we ran out. And now processors don't get faster, we just get more of them. It takes rewriting software from scratch in order to get that advantage. So I have been the training manager for the last 2 years on a software development process at Dreamworks to create a complete new body of software. It's really hard. And we've been using a new process in doing it called Agile Development. Folks know Agile here? Some? Programmers manage large, complex projects. We do too in the classroom. Teams have mixed skills and specialties. So do our students. Goals and content change dynamically. Yup, check. Great work requires iteration and refinement. Sounds like they're talking to us, doesn't it? So the latest project management techniques can help students and teachers succeed in managing group projects. You may be aware, this is a software management domain called Agile Programming. It started out with a manifesto, which I think is beautiful. We're uncovering better ways of developing software by doing it and helping others do it. And through this work, we've come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there's value in the items on the right, we find value in the items on the left more. So I took a shot, got a word processor, and I thought, what about a teacher's manifesto? We're uncovering better ways of teaching students by doing it and helping others do it. Through this work, we've come to value individuals and interactions over processes, working knowledge over comprehensive documentation, student collaboration over content negotiation, responding to change over following a plan. This doesn't seem too far from us, does it? So let me sketch a few ways that self-managed teamwork can be a part of your group projects in the classroom. Self-managed teamwork in the Agile model uses development teams, students, who do the design and implementation and testing. And there's a Scrum Master, student leader or the teacher, a person who keeps the process on track. And there's a product owner who guarantees that the right outcomes of the customer, the school, the education system, are met, the teacher. So Agile Development is a process for dynamically managing a team, students, producing a software problem or mastering a curriculum. The work happens in short sprints, each of the first few weeks. The team, students, determine what to accomplish in the next sprint based on the product owner's, the teacher's feedback. The product owner, the teacher, is always available during the sprints to answer the team's students' questions. The result of each sprint is a new completed version of the product. This is an incredible feature of Agile Development. At any point in a software project, at any point in a student project, you ought to be able to yell, "Done! What do you got?" And you shouldn't say, "Well, another 2 weeks and I'd have everything, but right now I got nothing." This was an incredible answer that came out of this development process and something we want in the classroom as well. I recognize we're close on time, so if folks have to go to make a plane or something like that, it won't hurt me too much. I understand. Thank you. This is an incredible idea, the idea of constantly working to an incomplete but finished product at every stage. The sprint begins with the Scrum Master, a student leader or teacher, running a planning meeting with the team, the students, to decide what to accomplish in that sprint, to develop a set of requirements. The requirements are then selected from the backlog, which is the yet uncompleted portions of the project, the yet unmastered portions of the curriculum, prioritized by the product owner, the teacher. The sprint ends with the team's, the students' delivery of the sprint's requirements, an incomplete but finished version of the product, of the curriculum, of the learning outcome. The retrospect meeting run by the Scrum Master, the student leader or teacher, with the team, the students, follows the sprint and reviews the progress and lessons learned for the next sprint. So this is all the students doing the work. They're managing the process. They're getting constant guidance from the teacher. And they're setting their own goals, looking at the great big basket of what we have to learn this year and picking out the next thing that they're interested in that they can build on and can deliver. You can see how this could be instrumental in using a set of groups in providing curriculum and answers and project outcomes to one another. This integrates well and scales for the classroom. Last topic I want to talk about, prototypes. This is an old exercise and you've probably run into it before. Can you name a colored tool? Just think about it in your head. Some tool? What color is it? It turns out We're very prototype driven. We have classes in our heads, and those classes have prototypes that are examples. And a red hammer is the answer that most people come up with. It's one of the problems with brainstorming. If you've got prototypes, somebody says blue, somebody else is going to say green. Somebody says blue, green, and they're going to say sky. And you can get these same answers every time. It's not a bad thing. It just should lead us to question the value of brainstorming as the single technique for discovering new ideas. One of the most important things that we teach our students is the ability to create classifications and understand them. Taxonomies, the science of classification, an arrangement method. And human beings arrange information in natural categories through taxonomy. Objects in the world, the great complexity of the universe, we can figure out how to deal with, because it was every instance we'd never manage it. We've got to bucket it up. How do we bucket it up? We look at the things that things do and the things that things know. State and behavior for each object allows us to group it together. Oh, all those animals that have backbones that bear their young live. Oh yeah, I can generalize about that. This taxonomy provides predictive knowledge. Oh, if I know that's a mammal, I know it's going to have certain behaviors. It raises its young, it bears live young. It's going to have some kind of culture to be able to keep that learning going. Figure out how to take advantage of those not very capable individuals that we bear as mammals. Objects are seen as members of types, and the types are arranged from very similar at the top to very different, each level defined by difference. So if you've got a kid who knows about horses and you want them to understand zebras, what do you say? It's a horse with stripes. And it turns out that that predictive information is at least fairly accurate. Things we know about horses do in fact apply in general to zebras, although interesting about zebras, never been domesticated. Horses have, obviously. All the domesticatable animals, we've gone through them. We tried everything, the ones we got that are domesticated. That's an interesting topic for another time. Object-oriented programming, then, is a programming domain in which objects have state and behavior, attributes and actions, like real-world things. And they're instances of types. These are classes defined by their shared attributes and actions. And classes are defined in an inheritance hierarchy. The most general class at the top, each class below a more specialized version of it. So here we have an opportunity to introduce programming for poets. One of the greatest things we can do in technology is to reach across the aisle and say, this isn't just for us. This is something that is good for everybody. Tastes good to solve problems. And artists have tons of them. The natural language features of things grouped by similarity in state and behavior, separated by uniqueness defined by difference. It's a technical language able to handle metaphor, analogy, story, and poetry. Racing to leadership. So I'm going to close with a story about a particular opportunity I had to teach where what was needed was leadership training. And I wanted to use a computer to do it because I'd heard a story many years before from my brother. I don't think it was that same night looking up at Sputnik, but it might have been. And he told me about spider driving. Ever heard of spider driving? So this is something that I've never gotten him to admit whether he did or just heard about. This was Tucson, Arizona, late 50s. And out in the desert, where there wasn't much danger, the kids would get together with somebody's car. It happened to be our family's Nash with a push-button transmission. Wow, that was cool. And in spider driving, the driver sat in the back seat and only gave instructions. And in the front seat, sitting squeezed over on the side, was one kid who was running the brake. In the middle was a kid who had his hand on the steering wheel. On the other side was a kid with his foot on the gas. The only thing they were allowed to do was to follow instructions. And the instructions had to be discrete. It couldn't just be stop, which would mean to get off the gas and press the brake. No, he had to give direct instructions to each of the participants in order to operate the vehicle. So I thought, this is a great leadership game. I got to figure out how to teach this. And I thought, all right, this isn't going to work for my clients as is. There must be something I could do. So I wrote a video game. And in this video game, the controls were separated out. And you could do this easily enough with most video games that you get off the shelf, right? As long as it had a discrete number of controls that could be explained. And the idea was to separate the game out into separate users. There was somebody who steered left, somebody who steered right, there was somebody who managed the accelerator, and there was somebody who managed the brake. And then there was the driver. to make it more interesting, to make it a little more fair, it seemed like, I blindfolded everybody, except for the driver. The driver was the only person who could see the screen. And everybody else, you can see it here. This is an example. They're wearing those plastic goggles, and they're blacked out in the front. That's a little more comfortable for my users. Let them wear their eyeglasses. Interesting, you want to keep your eyeglasses on while you're blindfolded? People do. It was an interesting discovery. Again, another discussion for another time. What was remarkable about this was the number of different leadership models that emerged almost immediately. We did it in part because this company had a yeller. You know, somebody whose management technique was the louder I get, the better you are. And it wasn't working for them. And he didn't really understand it. And so we did this as an opportunity both to explore leadership in general, but to also help this leader see different models in a practical sense. And what happened was he yelled, and his team got the worst time. And other teams developed models that reflected not what the leader wanted to do, but what was most effective for those who were learners, for those who were his students, for those who were doing the dance of leadership with him. The best one of them figured out singing. And by modulating his singing, high and low, warbling or not, he was able to completely control the 4 dimensions of information of turn left, turn right, speed up, slow down. It was remarkable, and his team actually won this first round of the leadership game. So this was actually a company in the UK, in Brighton, called BlackRock Studios, that makes racing games. It's one of Disney Interactive Studios. So for the end of the week, we needed to bring this leadership exercise back out to the full body of the company so everyone could experience it, because that's what learning is, right? Something that is uniquely transmittable and can be used by many different people for different reasons. So we rented a hotel ballroom. We laid a track out on the floor. We rented a tandem bicycle. And they repeated their leadership demonstration, racing in front of the entire studio, being held up on a bicycle. They're still blindfolded. Acceleration, brake, steer left, steer right, and hold the bike up, the added skill necessary in that particular race. So there are many applications of what we do with computers. None of them have to be in any particular way about computers, because nothing we do, except for those of us who get to program, is about computers. But everything we do is about engaging, about getting input, about providing output, about processing what you get, and about creating that queen in the annals of human interaction, which is collaboration, that moment at which we find ourselves all inside the same body wall. That's the difference, right? When you're a collaborator, it's a part of you. The other team members are a part of you. It's not like, boy, my liver is just not working today. No, it's my body. It's all the stuff inside that body wall that matters. And when we collaborate, we experience that. I'm basically done, but I feel like you've given so much. Having me here, working together, working for, you know, that 70% thing, it's not really scary. 70% of voters in California don't have kids in the system. Every one of us needs somebody to vote successfully on Social Security one day. We're not just involved, we're committed. This is a fabric that has no holes in it. Those 30% of parents who have kids in the school, the 70% of us who don't, we're all the same. We want playmates and friends and successful businesses and longevity. And those things all come from successful education of the next generation. It is our clearest domain. So I want to thank you with one small thing. Wisdom of crowds, you're probably aware of it, the thesis that diverse collections of independently deciding individuals are likely to make better decisions or predictions than individuals or experts. First discovered in 1907. The crowd at a county fair accurately predicted the weight of an ox when their guesses were average, closer than most individual guesses and all of the estimates of the experts. 5 elements of a wise crowd: diversity of opinion, independence, decentralization, and aggregation. I suspect that these are guidelines for what makes a great school as well. Failures of crowds: homogeneity, centralization, division, imitation, and emotionality. These are things that keep crowds from being wise. I also suspect they keep schools from being successful. Where do we want to be? Diverse, independent, decentralized, and looking for aggregation? Or seeing organizations that are too homogeneous, that are too centralized, that are separating their flows of information, that are repeating past decisions and react to peer pressure and collective hysteria? So to continue your independence and stay as a wise crowd, with the growing interconnectedness, keep your ties loose. Keep yourself exposed to as many diverse sources of information as possible, and make groups that range across hierarchies. Pixar tried a wisdom of crowd experiments. For Ratatouille opening, we were off by 50%. We guessed low. But for the final box office at the end of the year, we were within less than 1% in terms of the accuracy of our guess. And the next film that came out, completely off in terms of the final, but hit the opening grosses within that same range. You've heard the term 6 degrees of separation? It's really not 6 degrees of separation. It's the concept that any 6 of us connected together will get us to somebody else on the planet, and we're all connected. So 6 degrees of connectedness. And out of that came the idea of a Bacon number. Ever heard of this? How separated you are from Kevin Bacon? That is, if you made a movie with Kevin Bacon, you'd have a Bacon number of 1. If you made a movie with someone that made a movie with Kevin Bacon, you'd have a Bacon number of 2. Heard of the Erdős number? A great collaborator in mathematics, and many, many people wrote papers with Paul Erdős. So there's the notion of an Erdős number. I know people at Pixar who have both. And in fact, they talk about it as the Bacon-Erdős ratio. So I want to ask for something, and then I want to give the little gift I promised. Mentoring may sound like it's a lot of work and a big commitment. Sometimes it is. But in reality, every student I've ever talked to about mentoring has actually recorded the fact that it was a glancing blow. Someone who didn't even know they were a mentor. Somebody who said something that showed they took interest. There's no trick to be interesting. You can get a mohawk, enough piercing so that you whistle as long as the wind blows. Interesting's easy, but to be interested is a real gift. And when you share that interest with a student, that's mentoring. So I ask you, experience that glancing blow. Spend a minute with a kid you might not have talked to, a colleague, somebody. Next week, just recognize that your mentoring doesn't have to be a huge output. It just has to be a focused one. That's what I ask. What I give in turn is, I got a Bacon number of 2. We're on camera. So everybody, stand up, wave to the camera. We're making a movie together. You now have a Bacon number of 3. Camera, could you pan the room? Let's get all these wonderful filmmakers. Ladies and gentlemen, I appreciate your time and your interest. I, more than that, appreciate your willingness and your commitment. You all now have a Bacon number of 3, and I am proud to be a part of your little circle.